Okay, so we have talked about the peak to total ratio concept, right? Now I am going to talk about basically channel selection. So what is channel selection? First, you look over here. This is now when I was discussing peak to total ratio, I was talking about only a monoenergetic gamma ray source, right? So when I was talking about this peak to total ratio, I have only monoenergetic gamma ray source, and there I showed you that if the gamma ray energy is less than 1022 keV, we get a spectrum like this, where this is the contribution due to quantum background or incomplete energy deposition, and this is the full energy deposition, right? So it was much more straightforward in that way. But here now you see this is a realistic world that we live in, and monoenergetic gamma ray sources hardly exist, very rare. Now in real life experiments, be it stable ion beam or radioactive ion beam experiment, here I have shown you an example of a compound nuclear reaction. So here, during the de-excitation of this compound nucleus, I have shown you 6 possibilities. Now in real experiments, not just 6, maybe 20 or 30 possibilities are there. But remember, we are talking about possibilities. Not all possibility is equally probable. Some will have more cross section, some will have less cross section, right? Now that's a separate issue. But right now I am talking about, say, the fact that during de-excitation of this compound nucleus B star, 6 type of possibilities have opened up. Now out of them, suppose this X3 star, X3 nucleus, star means this is in excited state and this will be de-exciting by gamma rays. Now this is the nucleus of interest. That means I want to study the gamma ray spectrum of this nucleus. Now how am I going to study this? Am I going to study this when the experiment is being carried on, or will I be studying it later on? What do you think? How should I study? Even before doing the experiment, should I set up my apparatus such that I am only able to study this one? Will I do something like this, or will I make a general measurement and afterwards I will do the selection of this? What should I do? Tell me.
Generalized
Right. Because it is possible that right during the time of my analysis, someone has published this data. Then I will not be able to do anything, right? So it is always better to have as much as possibilities in your hand. It is very painful to do an experiment. Lots of resources have been utilized, not just cost. Lot of human management, hard work, many things are involved. So it is important that we get the entire data. Okay? Now how is it done? In actual experiments, we use least mode of data collection. I am not going to talk about it in detail, but just remember it, what it is. So basically, this is like a matrix, a single entry matrix, where the first one is the timestamp. Now timestamp, okay. Next one corresponds to detector 1. Next one corresponds to detector 2. Entry. What will be going in this entry? The amount of energy deposited. In this experiment, suppose, let me ask you, what detectors should I choose for this experiment? See here, alpha N, 2B, alpha, 2 alpha, alpha P, 3A.
Most of the particles are charged.
So basically we have charged particle plus neutron and also this star excited nucleus. So gamma detectors. So we will be using charged particle detector, neutron detector, and gamma ray detector. Now there may be several charged particle detectors. Say K1 number of detectors, this is K2 number of detectors, and this is K3 number of detectors, right? So here this will be entry. There will be an entry like this. So K1, similarly K2, similarly K3. You understand? So this is the disk mode data. So this K1 entry is for the energy deposited in the charged particle detectors, K1 number. This is for the neutron detector. This is for the gamma detector. This is how the data is recorded in list mode. Okay. Next, now I want to study this particular channel. This is known as channel selection. I have selected this particular channel. Now I am doing this selection in offline. After the experiment is done, everything is over. I have all the data with me. I am sitting in my laptop or computer. I am now doing this selection. Now it is possible to do this selection as well, selection of this as well. So let me first talk about this one. So while studying this, what I will do, I will put conditions. So what will be the condition? Number one, only one alpha detect. So in charged particles, I will be detecting only one alpha. What about neutron detector? No neutrons. And then gamma rays. So this will be my condition. So I will be detecting only one alpha, okay, no neutrons, and
Gamma ray is associated.
Whatever gamma ray is associated with these two conditions, just show me those gamma rays. This is what I will be putting the condition for selecting this particular channel, and then only I expect to get the gamma rays due to the X3 nucleus. But remember, even if we do this, due to accidental coincidence, there will be some gamma rays from other nucleus as well, because these selections might not be perfect. Okay, you have to keep this in mind. Okay, now let's talk about some other selection. So this was alpha plus X3 star. Here I have shown you, this is what I want to study, right? Gamma ray spectroscopy of X3 nucleus. Now, suppose I want to study this one. So, what should I put as a condition?
আমাকে একটা চার্জ পার্টিকেল
Two
detector
protons.
যাতে দুটো
So, remember, when I am saying
one alpha.
only one alpha detects, so this means only one alpha, no proton, right? One alpha plus no proton. Now for this one, I will be putting no alpha, two proton, no neutron, and then show me the gamma rays. Okay, so this is how I will be doing the channel selection. So everything will be done in the offline mode. Okay? Now, whatever gamma ray I will get, I will get. I cannot selection I am doing in charged particle or neutron detector. But again, remember, this selection is mainly on just whether you allow the charged particle or you don't allow the charged particle. But you are not doing any selection on the energy of neutron or charged particles. No energy selection. Here, whether present or not, this only. And then with this condition, whatever gamma rays you get, you get. You are not doing any energy selection here. No energy selection at this moment. Now, any more question?
স্যার যে এই টেনার স্পেসিসের পার্থক্যটা বললেন তো যে x3 যে স্পেকট্রামটা পাবো আসলে তো x1 x2 ওদেরও আমার
There is a possibility. Then I will have to suppose in the nucleus of X1. Let me give you an example. Here, this gamma ray is suppose 108 kV, right? And this is X1. Here, again there is some gamma ray 108 kV. Now I am getting after this suppose after this previous selection alpha plus x3 I am getting 108 kV in my spectrum. Now you might ask me, sir, 108 kV you are saying this belongs to x3, but 108 kV is also present in x1. So how do I confirm myself? Very simple. You take the entire data and do a selection. What you do, whatever you are getting 108, remember 108 kV is an energy, right? Now this energy gamma ray can be from many other nuclei. You have to select that 108 kV gamma ray which comes from X3. Okay? So what you do, you do a gamma gamma matrix. Gamma gamma matrix. There, for one gamma ray, you put 108 kV as a condition. What is gamma gamma matrix? Suppose there are K3 number of detectors, right? Now all the data in the K3 number of detectors, they can be put in the form of a gamma gamma matrix. One gamma ray versus another gamma ray. It means when one gamma ray is there, some other gamma ray must be there which was in coincident with it. And this is the meaning of saying preparing gamma gamma matrix, right? Now in the gamma gamma matrix, if I put a gate on 108 kV, then I will get only gamma rays which are in coincident with it, right? Now if my entire selection is good enough, then the other gamma rays will belong to X3 only and not for X1. Sometimes even we do gamma 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 matrix to be more precise. How to do that? For gamma 1 I am putting 108 kV, okay? For gamma 2 I am putting some other gamma ray of X3 and let me check. You understand? In this way you will be eliminating the possibility of gamma rays of X1.
স্যার গামা 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 ম্যাট্রিক্স যেটা করছি ওটা করে তো আমি আলাদা যে x1 থেকে বা x3 টা যখন
বাদ দিয়ে দিতে পারি। That is another way of channel selection. Okay, this is also a way of channel selection, but here I am using just gamma rays. Response function, I am talking about detector, separate detector. I have already showed you the response function for gamma detectors. For charge particle it will be approximately same like that, but it does not matter here because I am talking about whether I am taking the entire charge particle spectrum or not. I am not doing any energy selection over there. Okay, but here remember the very important difference. During channel selection, here no energy selection was made on this charge particle or neutral particles. But in the gamma gamma matrix, after this matrix is made, I can do energy selection in this matrix and then get the corresponding gamma ray.